Hello, and welcome to this pre-recorded event for the June 2015 examination for Unit C3 GCSE Chemistry. To help you get the most out of this feedback, you may want to have the following documents handy, as we will refer to them during the session. Here are the aims and objectives of today's session. You will receive feedback on national performance of candidates in Unit 3 of the June 2015 examination series. Consider the variation of candidates' performance on different questions and possible reasons why. Look at the examiner's report. Address common issues. The next 4 slides will look at question 6D of the Foundation Tier paper. This is a straightforward explanation about why some metal objects are electroplated. This candidate scores the marks for the points made about making metal objects more attractive and to prevent corrosion. This answer scored both marks for making the same points, improving appearance and prevention of corrosion. Some candidates find this topic on electrolysis very difficult, and this sometimes can prevent them scoring marks on issues that they would encounter in everyday life, such as this. On this question, it was also found that several candidates confused the issue of electroplating with alloying. Several candidates thought that electroplating would strengthen a metal. In this question, successful candidates understood the purpose of electroplating a metal. Could give at least 2 reasons for electroplating metals. The next 4 slides concern question 4B, part 3 of the higher tier paper. You will find it useful to look at this question on pages 10 to 11 of the question paper. You may wish to pause the video at this point to read the question. This candidate showed a clear understanding of equilibrium. Since there are fewer molecules on the right-hand side of the equation given on page 10 of the question paper, so an increase in pressure would result in a shift of the equilibrium to the products or right-hand side, and so increase the equilibrium yield of ammonia. This answer scores both points here. The answer this candidate gave shows an understanding of equilibrium and scored the marking point for stating that there were fewer molecules as equilibrium shifted to the right-hand side. Unfortunately, the candidate did not make a comment about the effect on equilibrium yield, and so did not score that mark. This answer shows that the candidate is confused by aspects of equilibria. The effect of increasing the pressure on a fixed volume of gas was understood. The volume would decrease. But this idea was not developed further to explain what would happen to the position of equilibrium, that is, move to the right, as that side occupies the smaller volume. And the effect on equilibrium yield was incorrect. In this question, successful candidates understood the effect of changing the pressure on the equilibrium position of a reaction. Expressed their answer clearly in terms of direction of change. Used the equation for the reaction to aid their explanation. Stated what would happen to the equilibrium yield. Look at this example of an answer to question 3C, Part 3, on the Foundation Tier paper. Using the mark scheme, decide what mark you think should be awarded and why. This is a point at which you can pause the video to look at the whole question on page 9 of the question paper and the mark scheme, and decide on the mark and why. This was a very good answer, and many candidates produced answers of this quality. Out of the 4 marking points available, this candidate's answer addressed all of them, and so scores the maximum of 3 marks for the question. Successful candidates identified the correct type of hardness for B and C. Used the results to explain why B was permanent hard water and C was temporary hard water. On this question, less successful candidates did not read the whole question and missed the point that A was soft water, stated that B was soft water and C was hard water, linked B with soft water because there was no change in volume of soap required after boiling, linked C with hard water because the volume of soap required after boiling had decreased. The next 4 slides are about the calculation in question 3C Part 2 of the Foundation Tier paper. Take a moment to read the question on page 7 of the question paper. You may wish to pause the video at this point to read the question. The first part of this candidate's answer was often seen, and it seems that many candidates think that hard water is bad, despite it being widely used throughout this country. The second part of the answer was insufficient to score a mark, as there was no mention of scale formation or the eventual blockage of water pipes. This answer was similar to the first point made in the last slide. The question asked for describe problems. A good answer to this question could have consisted of either simple descriptions of 2 problems, for example, the idea of scale and scum, or a developed description, for example, the idea of scale formation resulting in blocked pipes over time. This answer gives a developed description for scum formation and the wastage of soap, and so scored the 2 marks. Unsuccessful candidates thought that hard water is poisonous or caused illness of some description, often confused scale with scum. The next 4 slides are about question 6A, Part 4 of the higher tier paper. Most candidates performed well on this question, but others produced answers that demonstrated a poor understanding of how solutions conduct electricity during electrolysis. In this answer, the first point made was the idea of charged particles. For this question, charged particles were ignored, as that could have implied electrons were able to flow through the solution. As a result, only ions of some description were allowed. The second marking point was for the idea of ions moving, but this answer had the charged particles colliding, and so did not score the mark. This candidate possibly confused the idea of a metal conducting electricity with that of a solution, as it centered on free charged electrons moving around. In the mark scheme, the second marking point was dependent on the first, so in this answer, move around did not score, as it was not referring to ions. The answer given here contained both marking points with the solution containing ions which are free moving. Both marks were scored here. Unsuccessful candidates used charged particles in place of ions. Thought electrons were moving through a solution. Confused the ideas of conduction of a metal with that of a solution. Look at this answer for question 5A of the higher tier paper. Using the mark scheme, decide what mark you think should be awarded and why. This is a point at which you can pause the video to look at the mark scheme and decide on the mark and why. This was a clearly laid out calculation. The first marking point was for calculating the formula mass of calcium chloride. The second marking point was for calculating the moles of calcium chloride. The third marking point was for calculating the concentration of the solution. In this answer, all three marking points can be identified. On this question, successful candidates showed method of calculation in a logical manner, correctly calculated the formula mass of calcium chloride, either calculated the moles of calcium chloride and then the concentration of the solution, or calculated the mass concentration of the solution and then its concentration in mole per cubic decimeter. On this question, unsuccessful candidates made an error in the calculation of the formula mass, usually by not using the formula of calcium chloride as given. Did not know how to calculate the moles of calcium chloride. Did not know how to calculate the concentration of a solution from moles and volume. Set out calculation in a disorganized way. In order to improve their performance, candidates should learn the difference between molecular and structural formulae, learn the tests for gases and ions and the associated equations, learn the names of commonly used indicators for titrations and their correct color in different conditions, practice writing out different methods of salt preparation. Learn carefully the conditions for all of the processes in the specification. Practice carefully how to describe changes of equilibrium for gaseous reactions when pressure or temperature changes. Consider how an electrical current is transmitted in a metal, in graphite, and in an aqueous or liquid ionic compound. Learn which processes, oxidation or reduction, occur at which electrode.